Let's now turn to the back side of the sine law. We're going to look at some applications here, some word problems, if you will. Okay. Again, usually as with all trig questions, the hard part's on the picture. The math is going to be one of those two sine law questions we just did a second ago, but it's getting that picture figured out that's the hard part. So let's take a look at the first one here. A wall that's 1.5 meters tall. So look at this little clip art thing again. Here we have this wall. It's 1.4 meters. It makes an angle of 80 with the ground. And so if that's our ground right there, it's 80. And a 2-meter board is jammed between the top of the wall and the ground. So this board right here, like that, is 2 meters. And we want to assume the ground is level like we always do. What angle does the board make with the ground? Right, so the board and the ground is sort of down here at the bottom corner, right? That's part A. And how far is the base of the board from the base of the wall? Well, that's the bottom down there. Okay, I'm going to move the clip art piece away so we can take a look at the picture we just drew. Okay, there's our picture. There's all the parts and pieces that we need. Okay, I want to solve for x. Well, it's obviously not right angle. I got an 80 in there. So to solve this, I'm going to have to use the sine law. I need a pair of things that go together. It should be pretty obvious those go together. And a pair I want to solve, which looks like those two. So I know for sure that the sine of 80 goes with 2. And I know the sine of my angle, x, has to go with 1.4. And we're solving part A here right now, right? The angle. Okay, this is one of our two basic sine law questions. We did one of these a second ago. We had to solve for the angle. Cross multiply. 1.4 times the sine of 80 equals 2 times the sine of x. I want to get letters by themselves, so we need to get rid of that 2. Get rid of that 2. Remember, we cannot divide the sine because the sine is attached to the x, the sine of the angle, which we're trying to find. So we're left with sine x on the right-hand side here. And if we put everything into our calculator on the left, we end up with 0.6893 and a whole bunch of more decimals. And to get our answer, we need to take an inverse of that big long decimal, the second function, shift function, and try and keep as many decimals as you can. The more decimals you keep, the more exact your answer is. If you start rounding off, you're going to get the wrong answer. And if you do that right, you should get 43.58 degrees. Yeah, and on the angle of the board mixed with the ground. Part B wanted us to figure out how far the base of the board is from the base of the wall. Wanted us to figure out y. Well, to find y, I kind of need to know the angle that's opposite to it. And these two go together. Well, we're back to that idea that triangles add up to 180, right? We know x, we just solved that. So when I get the angle up here at the top, this one, I can take 180 minus the 80 we know for sure, minus the x we just found, 43.58. And I'll be left with that angle at the top, the one that's across from y. And that angle is 56.42 degrees. Okay, solve for y. I need a pair, and I got no pair. So what do we know? We know that sine of 80 goes with 2. We were told that in the very first example there, or very first part of this question. We now have an angle of 56.42. So I can do the sine of that with the side across from it, the y. And this goes back to the other kind of problem we can do, finding a missing side. So y times sine 80, y sine 80, 2 times sine 56.42. I want to get y by itself. I can divide out the sine part because I have the angle this time. So I'll cancel. And if I put this in my calculator, I end up with y being 1.69. Okay, so if we do our word problem answer, the board, the board is 1.69 meters from the wall. Okay, and really, that's just an application of how we can use the sine law, doing our two basic questions, finding a missing angle and finding a missing side. Okay, last one. It's a little bit trickier. You have to think a little bit about this one. See if you can draw the picture, see if you can interpret what's going on here. If you can do that, we'll talk about the math in just a second. You got a bridge across a valley 150 meters in length. So from one end of the bridge to the other end of the bridge is 150 meters. The valley walls, that's these little pieces right here, right? Okay, valley walls make angles of 60 and 54 with the bridge. So I'll say, well, this one's 60. I'll say this one's 54. And I want to know how deep the valley is. Well, the depth of the valley is the part that's straight down here, right? That part right there, which kind of looks like right angle triangles. And if I get rid of the clip part for a second, here we look at our diagram. Okay. I look at this and I say to myself, well, maybe I can use some SOHCAHTOA. But to do SOHCAHTOA, even though we have right triangles, I need to know how much either this side is from here to here, or I need to know what this side is from the center to here. And I can't divide the 150 in half because I don't know that half goes in one triangle and half goes in the other triangle. In fact, they can't be because the angles are different. So I cannot use SOHCAHTOA to solve this question, even though there's right triangles in it. I need to have some sine law applications here. So I want to know the depth of the valley. I want to know this value right here. I could, if I were able to figure out this piece or this piece, use SOHCAHTOA, because I'd only be dealing with one of those two triangles. And it's possible for me to figure out this side right here because it's part of the overall big triangle. In fact, y would be across from the angle 60. Right? So if I were to say sine 60, I know it goes with y, part of the big triangle. I also know that 150 goes across from the angle at the bottom down here, which is not given, but I know the idea of 180 minus 60 minus 54 will allow me to solve for that. And I'll get 66, which means I could solve the outside parts of this triangle using the sine law. I can cross multiply y sine 66 and 150 sine 60. Okay, divide out the parts I don't want. So that's the sine 66 here, sine 66 there. I'll end up with y equaling 142.2. Okay, why did I want to do that? Well, the reason why, because I couldn't divide the 150 in half because I didn't know the portions that were on either side of the bridge of those right triangles. But now I know that this is 142.2 meters. I know this is my depth, the part I want to find. And I know the angle in the top corner here was 54 degrees. I don't need to know this distance up here. And in fact, I can't know that distance up there until this point. Okay, so if I want to solve for x now, I can go back to right angle triangles. There's my opposite. There's my hypotenuse. That's a SOHCAHTOA question, right? And specifically the sine. So the sine of 54 goes with x over 142.2. We're going to cross multiply that. Okay, x times 1, x 142.2 times the sine of 54. Put that all in our calculator, and we'll end up with 115. So the bridge is 115 meters above the valley. Okay? That one's a tricky one because you have to start remembering ideas from SOHCAHTOA and sine law and start putting them together to realize what you can do with the two of them at one time.